here's a problem from chapter 4 where we're solving for centripetal acceleration, and this is about an airplane that's making a horizontal turn, like let's say from south to west or east to north, let's say. But let's draw a picture of these velocities they're giving us. So I'm going to draw an XY axis here. And first it tells us that we've got a VI of 400 in the X direction and positive 500 in the Y direction. So that would be a velocity, instantaneous velocity like that. And then the final velocity is negative 400 and negative 500. So it points like in this direction, okay? But if we're trying to draw the path of the airplane, then we might have to scoot those. So let's just imagine, okay, this is the initial velocity. Well, that's tangent to the flight of the plane. So you can imagine there would be a circle here, and I'll use my circle tool since I have one, where that is tangent to the flight of the airplane. So it might be coming right like that, so that VI is coming like that, and then VF is across the circle, lined up like that. So what's really happening here is the plane's only doing half of a circle because it's entering the turn right then and leaving the turn right across here. So when it tells us that the time is 24 seconds, we have to know enough or draw this in order to figure out that a full circle would take 48 seconds, which we call period, okay? And then we also need to find what's the velocity overall, which is really Vx squared plus Vy squared. We're using Pythagorean theorem here because we, in the equation for, oops, in the equation for centripetal acceleration, that's our new equation, we're going to need just plain old V, not Vx or Vy, but V. Okay, now it also looks like we need R, but they didn't tell us that. And so another useful thing to know is this equation that the velocity around the circle would be equal to distance over time because it's a constant speed. And the distance around a circle is 2 pi r, and the time around the circle is called the period. Okay, so then let's come around here and find V. So we're using Pythagorean theorem to say V is square root, and it doesn't matter if we do the initial or the final because these are constant, you know, one's set is negative, but when you square a negative, you still get the same number. So then we're going to get 640. Let's keep 3 sig figs. Okay. We're looking for AC. Well, we don't know R, but let's solve this one for R. So if I do that, I'm going to move t to the other side and then divide both sides by 2 pi. Then I'm going to substitute that in so I can go like this so that I can plug that in where R is. And if I simplify this, then one of the v's goes away and the 2 pi moves up. So and I've got 83.8, which then it asks for that as a multiple of G, which is about 8 Gs. Okay.